What if I told you that a Nobel Prize-winning physicist just confirmed the universe is breaking its own rules? And I'm not talking about some theoretical possibility. I'm talking about hard data. From the most powerful telescope ever built, the James Webb Space Telescope has detected something that shouldn't exist. Regions of the universe expanding at completely different speeds. For 100 years, every calculation we've made about the cosmos assumed space stretches uniformly. But if that assumption is wrong, then the age of the universe is wrong. The Big Bang timeline is wrong. Everything is wrong. And the scientists who discovered this? They're terrified. The foundation that crumbled. To understand why this discovery is so devastating, you need to understand what physicists call the cosmological principle. It's one of the most fundamental assumptions in all of science. It states that on the largest scales, the universe is homogeneous and isotropic. That's physics speak for the same everywhere and in all directions. This principle isn't abstract. It's the bedrock of Einstein's equations, the Big Bang theory, and every calculation we've ever made about the age and size of the cosmos. When Edwin Hubble discovered in 1929 that the universe was expanding, he assumed it was expanding uniformly, like inflating a balloon, where every point on the surface moves away from every other point at the same rate. That assumption worked perfectly. For decades, it allowed us to calculate that the universe is 13.8 billion years old. It let us predict the cosmic microwave background, which we then discovered exactly as predicted. It gave us dark energy to explain why expansion is accelerating. Everything fit beautifully. But here's the terrifying part. What if that assumption was wrong from the very beginning? What if we've been building our entire understanding of the cosmos on a foundation that doesn't exist? What Webb actually saw. The James Webb Space Telescope launched on Christmas Day 2021. And it's been revolutionizing astronomy ever since. Its infrared instruments can peer deeper into space, and therefore further back in time, than any telescope in history. But in early 2024, Webb made an observation that sent shockwaves through the physics community. It was measuring the expansion rate of the universe, using a method called the cosmic distance ladder. By observing Cepheid variable stars and type Ia supernovae, objects whose true brightness we already know. These are called standard candles. Measure how dim they appear, and you can calculate how far away they are. But here's where it gets weird. When Webb measured the expansion rate in our local cosmic neighborhood, it got a value of about 73 kilometers per second per megaparsec. That's the Hubble constant. But when other instruments measure the expansion rate using the cosmic microwave background, the afterglow of the Big Bang, they get a completely different number. About 67 kilometers per second per megaparsec. That's a 9% difference. In everyday science, that might not sound like much. But in cosmology, where precision is everything, that's catastrophic. It's like measuring the same road with two different rulers, and getting two different lengths. One of them has to be wrong. Or worse, they could both be right. And space itself operates under different rules in different regions. The Hubble tension crisis. Physicists call this problem the Hubble tension. And it's arguably the biggest crisis in cosmology today. At first, scientists thought it might be a measurement error. Maybe Webb was miscalibrated. Maybe there was bias in how we identify standard candles. But the more measurements we make, the worse it gets. The Hubble Space Telescope confirmed the higher number. Webb confirmed it with even greater precision. Ground-based observatories confirmed it. Multiple independent teams, using different methods, all got the same result. The local universe is expanding faster than the early universe predicts. Meanwhile, measurements of the cosmic microwave background, from missions like Planck, keep giving the lower number, with extraordinary precision. These aren't sloppy measurements. They are among the most precise observations in the history of science. And they fundamentally disagree. This is where Nobel Prize winner Adam Rees enters the story. Rees shared the 2011 Nobel Prize in Physics for discovering that the universe's expansion is accelerating, driven by dark energy. He's been measuring the Hubble constant for decades. And now, he's sounding the alarm. In 2024, after analyzing Webb's latest data, Rees confirmed our worst fears. The discrepancy is real. It's significant. And we can't explain it with current physics. Either our measurements are wrong in ways we can't detect, or our understanding of how the universe expands is fundamentally flawed. Why Nobel winners are worried? So why are leading physicists so concerned? Because the implications go far beyond a single number. If the Hubble tension is real, then one of several deeply disturbing possibilities must be true. First, the cosmological principle is wrong. The universe isn't uniform. Different regions expand at different rates. We might live inside a special region, a Hubble bubble, where physics works differently. Second, dark energy isn't constant. It might change over time, or vary by location. That would require new physics, beyond Einstein. Third, our distance measurements are fundamentally flawed. Or fourth, the most radical idea of all, the fundamental constants of nature might not be constant. Any one of these possibilities would shatter modern physics. Textbooks rewritten. The age of the universe recalculated. Our place in the cosmos re-evaluated. And scientists like Rees aren't speculating anymore. They're starting to accept that something has to give. Dark energy's dark secret. Dark energy makes up about 68% of the universe. Dark matter accounts for another 27%. Everything we see, stars, planets, life, is less than 5%. We discovered dark energy in 1998. When distant supernovae appeared fainter than expected, the universe wasn't slowing down. It was accelerating. We named it dark energy, because we have no idea what it is. The leading theory is that it's a cosmological constant, the energy of empty space itself. If that's true, dark energy should be perfectly uniform. But here's the secret. We've never proven that. We just assumed it, because it made the math work. The Hubble tension might be telling us that assumption was wrong. If dark energy varies, it would create regions with different expansion rates. Exactly what Webb is seeing. Some physicists propose dynamic dark energy. Others suggest entirely new frameworks, or even a multiverse. The most unsettling idea? Dark energy might not exist at all, and gravity itself breaks down on cosmic scales. What this means for reality. If different regions of the universe expand at different rates, then almost everything we thought we knew needs revision. The universe's age might depend on where you measure it. The Big Bang might not have been uniform. The fate of the universe becomes uncertain again. But here's what really haunts physicists. If we're wrong about something this fundamental, what else are we wrong about? Our cosmological model works, but it rests on assumptions we can't directly test. If those assumptions fail, we might live in a universe that only appears orderly. From our perspective, Webb will keep collecting data. Future missions will add more. But scientists are realizing this might not be a measurement problem. It might be a physics problem. And physics problems require new ideas. The next Einstein might already be working on this. Or maybe we're witnessing something even bigger. Evidence that the universe is stranger, more complex, and more wonderful than we ever imagined. One thing is certain. The crisis in cosmology isn't going away. And that might be the most exciting development in physics. In 100 years.